Welcome to AP Computer Assignment 11. The first assignment we're going to look at is write an application program that asks the user for two int values, then announces whether one evenly divides the other using the modulo. So I've made me a new class called Exercise 426. So, of course, I did my import Java swing J option pane. I did my public class exercise 426. And of course, I did my main argument. Then I set up my first two strings. The first string, I had the user input the first number. And the second number, I had the user input, and I called them string 1 and string 2. String num1, string num2. Okay, so I declared num1 and num2 integer parse int. Okay. And so then I took remainder of the first remainder. See, you're going to see if they can equally divide both ways, right? So first you check to see if you can divide 1 by 2. And you're looking at the remainder. Remember, the modulo here looks at the remainder, correct? Then you're looking at the other way around, dividing number 2 by number 1. So if it's a 0, that means it divides evenly, right? There's no remainder if there's a 0. Okay, so then you say number 2 divides equally into number 1 if this first situation is true. If the second situation is true, the second one produces a no remainder. You say number 1 divides evenly into number 2. So if neither one of these is the case, you say neither number divides into the other. And you have the two closing curly braces, okay? So that is exercise 426. Next, we're going to be in exercise 4.27. Revise the guess number game to say you're hot if within 2 of the right answer, you're warm if within 6 of the right answer, and too high or too low otherwise. I started out a little bit different, and actually some of this is for exercise 428 as well. So you can see from on this side, here's Adam's exercise 4, project 10, and here is my 411. Okay, so you can see what I've added here is I've added private Java utility randy2. I've added private int your answer and private string last answer. So you can see he's got in here public void play one game. That's not wrong. It's just that I did mine outside of the class and a little bit separately, as you remember. So don't think that because he has it here, he's wrong. He's not wrong, okay? Okay, so here's where my exercise 427 comes in. So it comes down to should continue, and then exercise 427 comes after. Now I've got two different 427s. I've got my answer and the book's answer. As you know, I probably like mine better. What I did was the question asks for, if it's within 1 or 2 of the right answer, tell the user he's too hot. If it's within 3 or 4 of the right answer, tell him he's too warm, or within 5 of the right answer, he's too warm. So I put in the absolute value of the result. Okay, the result being how close are you to the secret number? Okay, so I did it this way: absolute value. That means if it's a negative or a positive 5, negative or positive 4, negative or positive 3, negative or positive 2, negative or positive 1. Right? So I put in the respective, you're hot, you're warms, right? And then, of course, if it's greater than that, you're too high, and otherwise, you're too low. So this is how I just figured it out, okay? So you're giving him a couple of options there. Okay, then let's look at this other part of the exercise. This is the book's answer right here. Now, I'm not saying that they're wrong. It's just that I think their logic's a little different. It's not as straightforward. So what they did was they put out an integer called difference, and it's equal to its user's number minus its secret's number. Okay, so if the difference is minus 2 and the difference is less than 2 and the difference is not equal to 0. So there you go. So in other words, if the difference between the number and the secret number is within 2, it says you're hot. The dialog box says you're hot. However, if it's greater than minus 3 or greater than plus 3, and the difference is less than or equal to 6, see, it puts in there you're warm. Otherwise, if it's greater than 6, you put too high, or less than 6, you're too low. Like I said, it's just, I can see what they did, but to me, this is just a little more straightforward. So whatever you want to do, I don't care. Next, we're going to do the exercise 4.28. Revise the guess number game to have the program lie in 1/3 of the time that the guess is too high, it says it's too low, but never lies about the guess being too low, nor does it lie twice in a row. Exercise 428. We're looking at only the instance now. We're modifying this so that only the instance where the user's number is greater than the secret number. So what are we doing? We're generating a new random number. Okay, Randy2 is a new random number. So we're going to have a line number, and we're going to divide it by 3. Modulo produces either a 0, 1, or a 2 for a remainder. Remember, if you divide something by 3, you have a remainder of 0, 1, or 2. So in this particular instance, we're going to produce 0. So this is line number 0. Now this isn't going to be exactly true all the time. I'm not exactly going to give you 1/3, but this is the closest we can approximate that I can figure. So we're just going to do it this way. So if the line number is 0 and the last number equals truth, okay, so what's going to happen then? If you have, instead of saying the number's too high, we're going to lie and say it's too low. And we're going to put the last answer is a lie. Okay? So that will prevent it from having 2 in a row here, see? Otherwise, they're going to tell the truth and say that it's too high and generate a truth. And here, if you're going to put in an incident, if you're going to do it another way, you would increment line number, okay? But this time, we're just, like I said, we're producing it randomly, so we're not exactly incrementing a lie. But if you're doing some type of routine where you actually did it a different way, you would want to increment your lies, okay? Once again, you don't need to increment your lies. Why? Because we're randomly producing this number up here, okay? So otherwise, you're just going to tell the, otherwise what? You're popping out of this one. It's less than the secret number. So you're putting out too low, and the last answer is truth. Okay? So that's how we've got all bases covered. So, okay, that's exercise 428. In exercise 4.29, we're going to find the best strategy for getting the right answer in the fewest guesses for the revision of the guess number game described in the preceding exercise. Okay, it's obvious that the best way to guess the number, the fewest number of tries, is to start by guessing 50. That's half of 100, right? So if the number is too high, divide that in half and guess 25. If it's too low, it might be a lie, so you guess 50 again because you remember it can't lie twice to make sure it's too low. If it's too low again, guess 75. If it's too high, guess 25. So you keep dividing in half, right? And repeat with new guesses halfway between the known maximum and the minimum, making sure that any computer claim of too low, because too low might be a lie, right, is really too low by guessing the same number again. All right. So just write it out. Just file, save as, exercise 429. There you go. Okay, in exercise 432, we're supposed to write out the signature of each method called in listings 110 and 111. So what is the signature? The signature of a method is its name, followed by the types of its parameters in parentheses. Leave out the return type and the names of its parameters. For instance, the signatures of the three J option pane methods listed in 4.2 are as follows. So they give this one here, show message dialog component string. So here you're looking at the description of the show method dialog method. And so you're taking away the J option pane. So what are you saying? Show message dialog. So null is what? Null is a component, right? So you put component, comma, hi there is a string. So it would be show message dialog, parentheses, component, comma, string. So what would it be for the next one? So here is the show input dialog method. So the show input dialog method is right here. Forget the J option pane. So what's the show input dialog? You have that, and you have in parentheses a string. Okay? So there you go. It would be show input dialog string. That's what type it is, right? So let's look at the third example, show confirm dialog. So here's show confirm dialog. What's null? It's a component. What's again? A string. So your example here would be show confirm dialog component comma string. And the other three examples of listening were the signatures and the methods of the time class in listing 4.5. So let's look at that. So the first method is a constructor. So what are we looking at? Time, int, comma, int. Right? Is that clear? Right. The next one is the toString method. There's nothing in the parameters. You don't have to worry about that. And the last one is add, and the type is time, right? That's it. So let's go into the question. It says write out the signature of each method called in listings 110 and 111. So here is listing 110, prototype of the buy and hold portfolio listing of objects. So what's your first method? Describe investment choices. So do you have anything modifying that? Nope, just copy it. Okay, so let's go to the next one. Wait for years. That's the next method. We're going to take out the word years though. So we're going to copy this. Bring up Word. Paste it in here. Take out the word years. What's the next signature? Display current values. Copy it. Go to Word. Paste it in. Nothing more to that. Make sure you put down that it was listing 110. Next we go to listing 111. So here's listing 111. So we're going to copy here, draw tree double. Bring up Word. Listing 111. Take out the word trunk. Put their signature. What's the next signature? That's it. So there's your answers for the question. So just print it out like this. Your exercise 432, you're listing your signature for the method and listing 110, and your signature for the listing in 111. Exercise 433 is to write out the full time constructor for the heading public time int total minutes. Be sure to allow for negative inputs. Okay, some of the constructor is going to be similar to what you have in the time class. So let's look at the time class constructor here. Open the editor. And you can see down here, this construction is going to be the same, except for instead of having int hour, you have int total minutes here, okay? And hour will be equal to 0 because we're not really concerned so much about the hour, but its min would be total min, okay? That would be the difference. And then it would be pretty much the same as this is right down here. You put in for its min is equal to min, and its min less than 0 on its min greater than its min plus 60. Then you decrement the hour. So in this particular instance, you're doing what? The total minutes. You want to make sure that you take it from the hour, right? If it's less than 0. Okay, so you just keep on taking away the minutes until it's a positive number. Okay, so you keep on decrementing it, the hour, until the minutes are positive. Okay, so that's in the case that the minute's less than 0. What do you do if the minute's greater than 60? What you do is you keep on adding to the hour and subtracting 60 until the minutes become within the range 0 to 60. Okay. And here's a case for dealing with the hours. So if your hour is less than 0, you're adding 24 to it. If it's greater than 24, you're subtracting 24 from it. Okay. So that's how we're going to do that. It's going to be almost the same. So let's just write it out. So we start off putting in exercise 433. And then we initialize public time int total minutes, like I said. Then we put in super, telling us that this is a constructor, right? And we initialize its hour to 0. And we initialize its minute as total minutes. Then we take care of the situation where its minutes is less than 0. So we say that, we're going to keep on adding 60 minutes until it's a positive number, okay? And every time we keep on decrementing an hour until it becomes greater than 0. The other situation is if the number of minutes is greater than 60, what we do is we keep on incrementing the hour and taking away 60 from the minutes until it's less than 60. So that's the other situation. Then we handle the hourly situation. If the hour is less than 0, we add 24 hours to it until it's in a positive territory. Or if it's greater than 24, we decrement 24 until it's within 0 to 24. So that's how we do the total minutes for our constructor. So exercise 434 says write out the Big Vic constructor that listing 4.7 needs. I'd like to remind you that if you're going to compile this, obviously you need to go to your chapter 3 stuff in order to compile it with your VICs. But you can include it separately as a text file, as long as you make sure it compiles before you send it to me, okay? So let's go to the listing 4.7. Okay, here's listing 4.7, so we're going to copy it. This is on page 421, okay? 4 methods of the VIC class, so we copy it. Of course, we're going to paste it into our chapter, our chapter 3 stuff. So I go back in my chapter 3 assignments. Okay, we're going to do it in Looper. I come on down, and here's, I find space here. I'm going to paste that in there. Okay, so we have, here's our public Big Vic constructor. Left as an exercise. We need to fill in this. So what's the first thing you do? You got to bring in super. We're going to initialize a variable that's number filled equals 0. Then we're going to initialize another variable that's number empty equals 0. Obviously, we want a spotter in place to get the position. So we'll call our spotter spot and this get position, okay, to get position of where you're starting from so you can return there, right? So we're going to check a condition is does the slot exist? So while the slot exists, if the VIX sees a CD, it adds to the number of filled slots, right? And if it doesn't see a CD, it adds to its number of empty slots, right? Then it moves on to the next slot until what happens? When this is no longer true and it no longer sees a slot. So then what you have to do is you have to go back to where you left the spotter at, the first position where you started from. So what you say, while spot does not equal this get position, when these two are equal, then he'll stop backing up. So in other words, until this is true, he's still going to back up. Okay, so he gets back to his initial position. And make sure you have your ending curly brace. And that's all there is to it. Okay? So instead of you turning in this whole chapter 3 to me, just copy this constructor, beginning from where it says constructor, until you hit this particular thing. Just copy it, paste it into Notepad, copy it as constructor for Big Vic. Since you've already compiled it, right, you see that it works. Exercise 434. That's all there is. Okay, the last question. The rate possible assignments of true and false to the Boolean values B, C, and D. Which assignments give not B and C or not D, and not the negation of B or not C plus D. And basically, if you took these apart, you would see that these are exactly the same expression. But let's check it out using truth tables. Okay, in this first situation, not B, both of these have to be true. So not B would make these false. Everything, the first four would be false, no matter what the other side says. So, and C or not D. So C or not D, true, true, so that make this one true. True, not false, would be true, so that make that one true. False or not true would be false, so that make this one false. Then false or not false, this would make this one true. Okay? So this is the negation of whatever this says. That all these are the opposite. Okay, in this situation, any place where B is going to be true means that the statement's going to be true. So we'll go B's true here. True here. True here. True here. So this would be false if not C plus D is false. So we're going to look through, is D true? Okay, D's true except for, is D true here? Yes. Is not C true? No. So that's false. Okay, is not C true? No, that's false. So this is false. Okay, so not C is true and D is true, so this would be true. And finally, not C is true, but the other one's false. So let's make the last one false. Okay, so the negation of that, false and not true is false. 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 True and not false is true. True and not false is true. False and not true is false. True and not false is false. See what it is? Actually, you've just proven that no matter how you slice and dice it, these statements are the same. So you just have to say that there's no way you can slice it or dice it that you're going to get different values. So you can say no assignments give the two expressions different values. Just save this as exercise 437 and you're done with the exercises.